So let's look at the auditory system a little bit. I got this picture from the web, as you can tell. This is the eardrum here. These are the little bones. The amplifier system. This is the cochlea, where there's little hair cells that vibrate at different frequencies along the cochlea to represent different tones. And this information then goes into the brainstem, where you have a bunch of nuclei that further process the auditory information. After it's processed in the brainstem, it gets pumped up to the midbrain and then to the thalamus and then finally to the cerebral cortex. And here you have it. I just want to show you that the first station that receives information from the cochlea, which is outside of the brain, the cochlea is in the ear. It's the anterior ventral cochlear nucleus and the posterior ventral cochlear nucleus and the dorsal cochlear nucleus. These are the first stations. The first thing that comes into the brain auditorily ends up here. And then they go through all these nuclei and the brainstem until they get to the thalamus. This is something I told you. Then the first cortical representations, it's called primary auditory cortex, and then additional secondary auditory cortex, all the way up to the frontal lobe, which has to make sense out of this. It has to make it match to previous experience and learn the meaning of it, and when you use it, when you don't use it. In other words, the real human part is over here. Animals have all of this, and even some of this, but they just don't have much of this. Okay? And in functional terms, you have an auditory system that represents whatever sound comes in, which is a sound spectrum that you can plot as frequency and amplitude. And from that sound spectrum, you have to parse out the phonemes. You learn these phonemes by statistical exposure to your language. So you know that B is an entity, because it occurs in many places when you hear your mother talk. But this, but that. So you begin to say, hey, what must be something important, and that's your phoneme. And this is artificially applied to the sound stream by the baby. There's no B in the sound stream. There's just frequencies and amplitudes. So the phonetic interface is the beginning of language. Chinchillas can do it. And then there is a phonological grammar. You can use these sounds in certain ways in a language. You're not allowed to use them in other ways. There is a set of rules that governs how to use these sounds. Part of the rules have to do with what we call phonotactics, which is that there are certain sounds you can't put together because your mouth can't wrap around them. You can't pronounce a TQ sound or something like that, unless you're Polish. No. The Slavic languages, push this to a great extent. You've seen these names with C, S, Z, Y kind of things, but they're not pronounced as if you pronounce each letter. They sort of, but still, there are phonotactic limitations, but there's more than that. And for instance, in Hebrew, and I'll give you an experiment later, which is really interesting. In Hebrew, when you have a repeated consonant in a two-syllable word, it's legal to have the repeated consonant in the second syllable, not in the first syllable. Okay? There are no words in the language where the repeated consonant is in the first syllable. It doesn't exist. So if you produce a word, and you make up a word that has a repeated consonant in the first word, an Israeli Hebrew speaker says that couldn't be a word. It's just not a word, right? Just like you and I would think of pseudo words as being non-words. That's not a word. And then so there are rules of how you can combine these sounds, and that's more advanced. That's already talking about the cerebral cortex. And then there are rules about how to put these things to get meaning into words. So this is all happening bottom up. And the little children and babies, they're working with this. They're trying to figure out what the sounds are to begin with, and how do they go together. even before they know any meaning. A 9-month-old baby doesn't know much meaning of anything, but already has a full representation of those sounds in the brain.